So I have the following Fourier series representation of the function f of x, which is equal to the absolute value of x between 0 and 2 pi, and that is a 2 pi periodic function. So if I calculate the Fourier series representation of that function, I get pi over 2 plus the sum from k is equal to 1 to infinity of minus 4 over pi times k squared times cosine of kx. Yes, so our a sub k, so our a sub k coefficients are equal to minus 4 over pi times k squared, so those are the coefficients in front of the cosine of kx. The b sub k's are 0 if you calculate the Fourier series representation of that function. B sub k are 0, that's why we have no sine of kx, because remember that the b sub k are the coefficients in front of the sine of kx. We have no sine of kx, so yeah, we have no sine of kx because the b sub k are 0. And our a sub 0 is equal to pi. And remember that this pi over 2 is equal to our a sub 0 over 2. Remember, we have this formula with a sub 0 over 2 plus the sum from 1 to infinity of a sub k cosine of kx plus b sub k sine of kx. Yes, and this result here is only valid for k odd, if k is an odd integer. Remember that if k is even, if you compute the Fourier series representation of the function, you will see that for k even, you simply get 0 for the whole thing, and that's not what you want. Yeah, so our goal will be to evaluate the following sum, the sum from n is equal to 1 to infinity of 1 over 2n minus 1 to the 4th power. And we will do that using the Fourier series representation of that function. Yes, so the first thing we will do is let k be equal to 2n minus 1, because remember I said that k is odd. And so we get pi over 2 plus the sum from n is equal to 1 to infinity of minus 4 over pi times 2n minus 1 squared. So instead of k squared, I have 2n minus 1 squared. And instead of the sum from k is equal to 1 to infinity, I have the sum from n is equal to 1 to infinity. And I have times cosine of 2n minus 1 times x, okay? Instead of k, I have 2n minus 1. Yes. So now I can use Parseval's theorem. You can look it up if you don't know about it. Parseval's theorem for Fourier series, which states that 1 over pi times the integral from minus pi to pi of f of x squared dx is equal to a sub 0 squared over 2 plus the sum from n is equal to 1 to infinity of a sub n squared plus b sub n squared. That is Parseval's theorem for the Fourier series. Okay, so f of x is our function here. In this case, the absolute value of x. And yeah, a sub 0, a sub n, and b sub n are our coefficients. Yeah, so if we do that, we get 1 over pi times the integral from minus pi to pi of the absolute value of x squared dx, and is this part here, is equal, if you evaluate that integral, you get 2/3 pi squared, and that is equal to pi squared over 2, so a sub 0 is pi, a sub 0 squared is pi squared, over 2, plus the sum from n is equal to 1 to infinity of 16 over pi squared times 2n minus 1 to the 4th power. So this is simply our a sub n or a sub k squared, okay? Remember a sub k is minus 4 over pi times k squared, so minus 4 squared is 16, pi squared is pi squared, and remember k was 2n minus 1, and it was squared here. Yeah, because k was squared, so we have 2n minus 1 squared, and now if we square it again, we get 2n minus 1 to the 4th power. Yes, and so you can already see that we have 2n minus 1 to the 4th power, like here in this sum, and so we are on the good path. Now we need to solve a bit, rearrange, and we will be able to evaluate this sum here. Yes, so we can take this pi squared over 2 on the other side, so we get 2/3 pi squared minus pi squared over 2, okay? And we can multiply by pi squared and divide by 16. So we have times pi squared over 16. And now that is equal to the sum from n is equal to 1 to infinity of 1 over 2n minus 1 to the 4th power. So that is my my sum here. Yes. So yeah, we removed this pi squared over 16 by multiplying by pi squared over 16. And so now we simply need to evaluate these two for pi squared minus pi squared over 2 times pi squared over 16, and we get pi to the fourth power over 96. And that is the result, that is the value of this of the sum of from n is equal to 1 to infinity of 1 over 2n minus 1 to the fourth power. Yes.